Okay, so we have the transfer function set up, but we also want to have the transfer from. Now, what's the difference between transfer and transfer from? Well, transfer from, essentially what that allows for the tokenomics of our smart contract here for this mock tether token is that it allows for third parties to run transactions. And then with the approval, because we're going to remember, we're going to write the approve event as well. So with the approval, then these third parties can then do events such as, pay for gas fees, make and do transfers on behalf. So you've probably seen that on dApps in the past. And so let's go ahead and write the functionality out for our mock tether token. So what we want to do is make another function and call it transfer from. And we're going to do another address, but this time it's going to be from. We're also going to have our address too, and we're going to have a uint 256, which will be our value. Oh, and you know what? In our function transfer, let's also make the integers here 256. And we're going to do a public returns, again, bool success. Okay, and what can we add here? Well, we know that we want to do the same thing. We want to do the same thing here with our balance. So we can say balance when we add, what we're sending it to, we want to add to the value. What about from? We can do the same thing here. And for from, we don't want to be adding, right? We want to be subtracting the value. Balance, transfer from, okay? And we want to end it the same way here, right? We want to emit this transfer using from, to, and our value. And wait, hold on. There is a mistake in the transfer function that I just noticed. Can you spot it? If not, anyway, it's just an auto mistake because I just auto filled in emit transfer, so it brought in the from. But really, when we're transferring here, we don't have a from. Our from value for our emit transfer technically is actually the message sender, right? The person currently with the contract. So message sender. But here we are actually using the from address. Okay, so now for third parties, we have a balance to where we can add to the third parties the balance from, which is going to take away, and we emit the transfer. But we don't want this to just happen willy-nilly, right? We don't want our investors or customers to feel like, oh man, wait, did that just happen? Why couldn't I have had the option to approve? They need to physically go through that additional security measure. That's why we started writing out our approve event as well. So what we want to do is create an allowance in order to execute this as well and add this to our transfer. And in order to do that, we're going to create another mapping. So I'm just copying our mapping over here, and we're going to make it public. We're going to call it allowance. Okay. And what we're actually going to do is we're going to map into our mapping. So we're actually going to map into our mapping like this. Okay, this can look a little confusing, but really essentially what we're doing here is we just have a mapping that we're sending an address to. And then of those addresses, we're doing the same thing. We're mapping and we're providing a key store value for each address. And this is all going to be set to our allowance. All right. So that's how we're going to be able to keep track with iterations for our allowance. So now that we have our allowance mapping set up, let's go ahead and add the allowance functionality. Oops. And here, let me fix this. All right. So we're going to bring in the allowance in our function transfer from. We're going to say allowance. And what's the allowance going to be? It's going to be message.sender. And it's going to be from minus equals underscore the value. And we don't need these comments to be out so much like that. Here, let's actually just bring them in. So what does this all mean? Well, remember, it's our allowance. Well, our allowance comes from the message sender, and the address is from, is going to be equal to the allowance of the message sender from minus the value. The caller's allowance from sender is reduced from the amount, okay? And finally, when we're doing these third-party transactions, we should also have some requirements set in. So the first requirement we can add here is that the value is going to be greater or equal to the balance of the address from the address that you're sending. So we require, so this way, this ensures that when we're receiving these, when we're doing these transfer froms, the value will always be greater than or equal to whatever the balance is happening. So we don't want it to ever be lower. We don't want it to ever be lower than that. And we want to do something similar for the allowance as well, right? So I'm just going to copy paste this, and we're going to do it for the value of the allowance from the message sender, right? And I made another mistake. That's okay. Coding is all about making mistakes, but then correcting them, figuring out what they are. So it's not that we don't want to require that the value would be greater than or equal to the balance of, because that would pretty much just stop everything from happening. We want it to be less than or equal to the balance of. And same thing here. We want also, same thing with the allowance. We want to check to see that the value that we have here is less than or equal to the value of the balance from the address. Okay, and that's it for our transfer from, and that's it for the transfer from function. It's a little bit more, there's a little bit more logic, but it's not really so bad, right? When we're doing the transfer from, we just use the balance of the address to where it's going is going to be whatever that balance already is, plus the value that is being transferred from that. And we do the same thing for from, except we don't want to be adding. In that case, we want to be subtracting. Then we have an allowance here so that we check the message sender with the address, and we subtract from what the value is to that. Okay. And then finally, we make the requirements so that the value is less than or equal the balance of the address where it's going from where it's being transferred from, and as well as checking for the allowance with the current contract. We're almost there. Let's go ahead and write the final functionality for another layer of security and add this to the smart contract as well. And what we're going to do first actually is I'm going to change this event from approve. We're going to call it approval, okay? Approval. So the tense makes a little bit more sense. And we're going to write in a function over here. So we're going to write function approve here. And we're going to take two arguments here. We're going to take a spender to be approved and a value in the arguments. And we can hopefully you know now that this would be uint. And spender is going to be our address. And again, it's going to be the same thing, public returns bool success. Okay. And sorry, it's returns. All right, so how do we write the approve function here? Well, we want to go back to our mapping with our allowance. And what we want to do is we want to say our allowance, and we'll set it to the message sender. All right, and we're going to check for the spender, and we're going to set that, and we're going to set this equal to the value.